Hello, everybody. Here we go. So it's the only constant is change, right? And many applications we're working on use time series data. These time series data could be generated from sensors or from event sequences. Now, in engineering, where I'm from, only when we want to solve problems, we need to understand the domain expertise, and we need to set up predictive models, and then in the end combine this with a decision model to really come up with a conclusion and act on what we have observed. Now, these decision models could either be how many sushi rolls to solve, some reoccurrence, like in the top right and the bottom right. If we know events, or we have an anticipation when events are going to happen, we can combine these anticipation with a complex event processing model and then act before something really happens. So this is very important for any engineering processes. But how to create these models if you were working on time series? So if you look at the top left, so this is an example from time series classification. You cannot see anything here, but the general idea always is you want to make, for example, a classification change between two, say, okay, labels on observed time series. For example, this is running, this is walking. And in many situations, you do not have one, but several different time series at the same time. And what we are proposing and what we want to present here is a method which automates the extraction of time series features from time series, which in the end removes the task of manual feature engineering from time series and opens the way of thinking which time series should I generate in order to get the best features. Right? For example, if you have got two synchronized sensors, you could generate a new time series, which is the difference between the two sensor signals, and generate features from that. Now, let me show you some examples. Right? So in general, we've got these 4 steps. We've got time series engineering, right? So converting the time series into features which we can use. Then, they get the time series, then extract features from that. But many of those features, especially if we have just an approach where we use many different algorithms which have been proven to be useful in some applications, many of those features might be just noise. So we need to have some feature selection to get rid of the redundant features. And after the feature selection, we typically do a supervised machine learning algorithm. Now, some examples of how you could use these approaches. For example, activity recognition, right? You could have sensors on the left and right ankle, do different activities, and then discriminate running by walking. But you can, because the sensors are synchronized, you can generate new time series, namely the difference between two sensor signals, acceleration in x direction, for example. And then using this, you can, if you follow the top stream to the right, then you can easily compare 10 different activities just by using combinations of different sensors. These applications also work not only for time series, but for ordered data of any type, for example, spectra, right? They are ordered with respect to wavelength, and you can then use these applications for non-destructive measurements. But surprisingly, these approaches also work for data sets which are not time series, for example, images. Right? So, for example, if you want to distinguish properties which have pool from properties which do not have a pool, you could just use all the concatenate the rows of those images into a long vector, interpret this as a time series, extract features, and then train a classifier. And what we observed is that these algorithms work quite well even with few samples, just presenting 1,000 samples of properties with pools, without pool, and the algorithm can distinguish them quite well. The same performance in a convolutional neural network needs millions of images, right? So this is an approach when you have just a few samples. But it also works for written text. This is a collaboration with Kelly Blinko. He's also in the audience. So you could, for example, interpret written words as a time series, for example, by counting the number of characters per word. Right? Then you get a sequence of word lengths, can extract features, and you can use this for discriminating the writing styles of different authors. Right? So this is the bottom stream which you're seeing here. Now, to pitch this, if you want to use this technique, there's a library, TS-Fresh. It's not as famous as Vita right now, but we've staked our claim. It's published on GitHub and Anaconda, and yeah, it extracts nearly 800 features per time series, combines this with univariate feature selection, and is used in lots of different projects worldwide. So if you're working with time series, try out TS-Fresh. Thank you.